Good evening, everyone. Welcome to Second Math Hub, the solution to your math problems. We are still on bearings. We are looking at distance bearing problem. This is our third question. I read: a ship leaves Port P and sails on a bearing of 45 degrees northeast to Port Q, a distance of 15 kilometers away. So let's represent the first statement on the diagram. So between Port P and Port Q, where are you to measure the bearing 45 degrees northeast? So since the ship leaves Port P, so that is where we are to measure the bearing. It's left Port P. So let's measure 45 degrees northeast from Port P. This is our north, this is our east. So 45 northeast. So this is a compass bearing. So it means that starting from the north, you have to measure 45 degrees towards the east. So that should be somewhere here. So this angle here measures 45 degrees, and that is Port P. That is Port P. And here will be what port should be here? So to Port Q. So here will be Port Q. So we have our Port Q here. And what is the distance between the two ports? 15 kilometers. So that is the distance between the two ports. So we are done with the first statement. Now the second one. It then sails on a bearing of 45 degrees southeast to Port R. So where is the ship now? So the ship is at Port Q. So from Port Q, it sailed on a bearing of 45 degrees southeast to Port R. So from Port Q, there's our north, there's our south, and here is our east. So we have to measure 45 degrees southeast. 45 degrees southeast means that starting from the south, we have to measure 45 degrees towards the east. So that should be somewhere here. So here will be 45 degrees. That is 45 degrees southeast. Starting from our south, we have to measure 45 degrees towards the east. So this is where we place the 45 degrees. And what port is located at this point? So what port is located at this point? So to Port R. So here is Port R. That is our Port R. And what is the distance between Port Q and Port R? That is 20 kilometers. So now what are we supposed to do? We have to calculate correct to the nearest whole number, meaning that our final answer must be corrected to the nearest whole number. I, the distance from P to R, the distance from P to R. So how do we get a distance? So we have to join the 2 points. We have to join the 2 points. So we are looking at this distance from P to R. So now, as I said, since this is common, always your triangle must be, in most cases, it must be a right angle triangle, meaning that one of the interior angles must measure 90 degrees. So let's check which side, or yes, which side will measure 90 degrees. Now, this angle here measures 45 degrees. So what angle should be here? So if you can recall from plane geometry 1, angle properties of parallel lines. You have a parallel line, you have a parallel line. These are transversal. So these two angles here are alternating. They are formed from the alphabet C, and then we know that alternating angles are equal. So if this angle here measures 45 degrees, then this angle too should measure 45 degrees. And what is 45 degrees plus 45 degrees? 90 degrees. So we now have our 90 degrees angle. So clearly this is a right angle triangle. This is a right angle triangle. So how do we calculate the distance between port P and port R? So we must refer from Pythagoras theorem. So what does this theorem say? This theorem says that the square of the longest side is equal to the sum of the squares of the other two sides. So clearly you could see that there is the longest side because it is the side facing a 90 degrees angle. So I'm naming the longest side as line PR. So line PR squared should be equal to the sum of the squares of the other two sides. So one side is measuring 15 kilometers, so 15 kilometers squared plus 20 kilometers squared. So we have PR squared. Now, from our calculator, what is 15 squared? So we have 225. And then 20 squared. That is 400. So we can still simplify. 225 plus 400, 625. We are looking for PR, not PR squared. So we can take the square root on both sides. So the square root will cancel out the square. We are left with PR is equal to square root of 625. That is 25. So meaning that the distance between PR measures 25 kilometers. So that is the I part of the question. We are done with the I part. Now the II, second part. We have to find the bearing of P from R. What does that mean? The bearing of P from R. So it means that from R, that is where you measure the bearing. So from the geographical north, we have to move in the clockwise direction until we get to the line that connects port P. So we are looking at the measure of this angle here. So how then do we do that? So let me get some space here. So first of all, let's calculate the measure of this acute angle here, theta. Let's measure theta, the acute angle here, theta. Let's measure it. So how do we do that? Since there is a right angle triangle, we need to identify the sides. So there is the acute angle. It is facing this side. So this side becomes the opposite. We know that this side is our hypotenuse because it is the longest side. Again, it is the side facing a 90 degrees angle. And then obviously, the remaining side will be our adjacent. So you can see that we have our opposite, and then we have our adjacent. So from SOHCAHTOA, which of them has opposite adjacent? Opposite adjacent. So you see that is TOA. So what does TOA say? TOA says that the tan of this angle here must be equal to the length of the opposite, which is 15, divided by the length of the adjacent, which is 20. We are looking for theta, so what do? We need to take the tan inverse on both sides. So we take the tan inverse here, the tan and its inverse will cancel out, leaving theta. Then we have the tan inverse of 15 on 20. So from our calculator, what is the tan inverse of 15 on 20? So we have 36.87 degrees. So that is the measure of theta. Theta measures 36.87 degrees. Now let's look at something. What is the measure of this angle here? We are focusing on this quadrant. This quadrant. What is the measure of this angle here? So if this angle measures 45 degrees, if this angle measures 45 degrees, so we are seeing alternating angles, and we know that alternating angles are equal. So this angle here also measures 45 degrees. So you see that there is a remaining angle here. There is an angle here. I'm naming the angle as alpha. So let me name the angle as alpha. Alpha. So I'm naming there is an angle here. I'm naming it as alpha. Now, let's focus on this quadrant. You see that this quadrant has been divided into three. One part measuring alpha, one part measuring theta, one part measuring 45 degrees. And we know that the total measure of a quadrant is 90 degrees. So let's do substitution and solve for alpha. Let's solve for alpha. Let's solve for alpha. So from this quadrant, we know that alpha plus theta. What do we get for theta? So theta is 36.87 plus 45 degrees must be equal to the total measure of a quadrant, which is 90. So let's solve for alpha. So what is 36.87 plus 45? So alpha plus 81.87 is equal to 90. Let's make alpha the subject. So 90 minus 81.87. So alpha is 8.13 degrees. So that is the measure of alpha. That is the measure of alpha. Now that you know the measure of alpha, you should be able to calculate the bearing of P from R. So the bearing of P from R. Let's do the calculations here. Bearing of P from R. So from the geographical north in the clockwise direction until we get to the line that connects port P. So what is the measure of this angle here? 90 degrees plus the measure of this angle, 90 degrees plus the measure of this angle, 90 degrees plus the measure of alpha, this alpha. So alpha is, so plus alpha 8.13 degrees. So we have 90 plus 90 plus 90 plus 8.13. And that is giving me 278.13 degrees. Don't forget that we are asked to correct our answer to the nearest whole number. So to the nearest whole number, that should give us 278 degrees, 278 degrees. So this is the second part of the question. 278 degrees. So that brings us to the end of today's episode. I hope you enjoyed the lesson. See you next time.